Okay, in this video, we're going to be talking about matrices, finding what we call the inverse matrix. And anyway, to begin this, we're going to talk about I feel, the two most important numbers in mathematics, and that is the number 1 and the number 0. And the reason why this is so, we're constantly trying to get expressions to simplify to 1 and trying to get them to go to 0. We do that all the time to try to solve equations. And the same is true with matrices. So let's come up with a nice simple equation here to use. And let's see, let's use 2x, say plus 4 equals 10. So this is a nice, easy linear equation. We want that 4 to go to 0. So there's a use of 0. And to do that, we'll take the additive inverse. So 4 add a negative 4, or 4 subtract 4 will give me 0. And then the algebra says if I do it to one side, I have to do it to the other. So we end up with another expression or equation. It's called 2x equals 6. Now, another idea that we talk about is getting things to go to 1. A lot of times we look at it as division, but it's really multiplication by a reciprocal. So if you look at 2 over 2, 5 over 5, 110 over 110, they all equal 1. And so I think the point from this is there's a lot of ways to write the number 1. In this case, we're going to use 2 over 2. And the reason why I do 2 over 2, I want to have 1x. I don't want to have 2x's. I don't want to have 3x's. I want to have 1. So I divide that by 2 to give me that 1. And then 6 divided by 2 on the right-hand side solves that equation, and I get x equals 3. Well, the same idea is with matrices. We have an idea that's called an inverse matrix. And anyway, that's the same idea as reciprocal. So if I had 2, the inverse of that would be 1/2. In other words, the reciprocal. So take 2 over 1, we multiply by 1 over 2, and what do we get? We get 1. Now, it's important to remember that in mathematics, there's really no such thing as division. All there really is multiplication by the reciprocal. That's how division is defined. So the same idea is with matrices. If I take the A, I times it by its inverse, I get something that's called I. And that I is called the identity matrix. And if you look at it, you can see that it has a diagonal going from the top right down, top left down to the bottom right. It's 1. And the same way is true with a 2 by 2 matrix. Okay, in this next video, we're going to be writing the inverse matrix. So it's the inverse, it's the same idea as reciprocal, but we're dealing with matrices. Now the first thing we have to do is define the determinant. So we have to define the determinant of that matrix right there. Once we find that, we have to do what we call the adjoint matrix. And we multiply those two pieces together, and that gives us what we call the inverse. Now, if we take the inverse and times it by the original matrix, it will give us an identity matrix, and it has a bunch of diagonals. It has a diagonal from the top left down to the bottom right made of 1s. Okay, let's begin by taking the determinant first. Let me go ahead and zoom in here a little bit. Now we've done a lot of these, so we'll take the -6 times diagonally to the +1, and then we'll subtract the 7 times the -4. -6 subtract the -28. That 28 becomes positive, so -6 plus 28 will give me the 22. That is the value of this determinant. So the first step in finding the inverse function or the inverse matrix of a 2 by 2 is to take the determinant. We know that's 1 over 22. Now we have to apply that idea right there. So when you look at it really close, is that we need to take the -6 and 1 and those two things are going to switch places. So the -6 will move down to the 1 place, and the 1 will move up to the -6. So we'll have 1, -6, and then the 7 and the -4, they don't switch places, they just change signs. So I'll have a -7 and a +4. That matrix right there is the inverse. So the 1/22 is the scalar, and the matrix that we multiply that scalar by is 1, 4, -7, -6, and that's how we find the inverse matrix. Okay, next we're going to use this matrix calculator that I found online to create the inverse, and we're first going to go ahead and calculate it by hand. I'm going to set me up a couple of braces here to get started. And the first thing we have to do, remember, is to take the determinant. We're going to use the reciprocal of the determinant. Remember, it's over 1. So I take 10 times a -6, and I'll subtract a -7 times 6. So that's a -60. Subtract a -42, which will make it a +42, and I end up with a -18. So that's the determinant. Go ahead and erase that. Okay. And so remember that determinant is going to be a scalar out in the front of the adjoint matrix that I'm going to create. Now, as we went over before, the 10 and the -6 are going to trade places, and the -7 and the +6 are just going to stay where they're at. They're just going to change signs. So let's go ahead and do that. So that is the inverse matrix right there. That's it. That's like the reciprocal. I take that inverse times it to the original, and it'll give me the identity matrix. Now we're going to go ahead and use the calculator. The first step that you want to do is just to type the values into your matrix. Always type it in A first, because that's the only one that we can take the determinant of, is matrix A. Now we're going to go ahead and hit determinant. That's a -18. It's the same thing that we got, so we know we're doing this thing right. Okay, the next thing that we have to do is we want to type that value in that little window there. It's going to be used as a scalar later on when we take the inverse. Now we're going to take the inverse of that matrix there. So click the button, inverse of A, and you can see it gives us an inverse, and it's different from the one that we have because the 18 has been divided in, and we want to reverse that division by 18. Now you want to take that value in that white window, that big window, and you want to send it to B. So click to B, and you can see that it goes in there. Now we're going to take that -18. It's been divided in by the online calculator. We're going to multiply it back out. And now when we multiply it back out, you can see that we get the matrix that we have there on our paper. -6, -6, 7, and 10. Okay, so that's how that works. So this next part, we're going to actually check to see if we've got the right answer. We're going to take matrices A and B and times them together, and if we have the right inverse, we should get a identity matrix. And you can see in the window A times B, I get that diagonal 1. I have the 0 on the bottom left-hand corner, and for all practical purposes, that -4.4400 times 10 to the -16th, that is also a 0. So when you type these in, you can kind of test things to see that if you're getting the identity matrix once you're done, and it should all work out.